we will analyzing the real-time data that I have taken from the Kaggle.com. That is the website. So basically, this is the bike sharing data. So we will talk about this data set later. So let me start with how we can you can say load the library of the pandas, or you can say how we can call the library of the pandas. So there is a two methods because we want to use this library of the Python. So we will write down either import pandas, or either you can use the second type of the library, second way of calling the library, that is from pandas import static. So either way is the correct way. So the next thing is, if I want to check what kind of panda version I am using, so we can use pandas, right? That is the library, or you can say that is the package, dot 2 times underscore. So 2 times underscore, then we will write on version, and again 2 times underscore. So once we write down this one and then run it, we will get the pandas library. The pandas version, we will get it. So that is right now I am using 1.0.1. So that is the library, and then after clicking it, we can see the version of that one. So the first thing what we are going to see is how I can load the data set. So the data set I have available over here, that is in my G drive. So let me show you over here. So this is my data set. So how can I read this? And that this data set is in a CSV format, that is comma separated version format. Okay, so how we can read it, that is, first of all, I have to write down the pandas, that is the name of the library, dot read underscore CSV. So that is because we can read the multiple type of the data files, CSV or text file, and there are multiple type of the files we can read it. So right now my data set is in a CSV format, that's why dot CSV. Then we can say bracket start, then in inverted commas I have to give the path, but make sure that you should use the front slash, right? If you use the backslash, then it will give you the error. Okay, so I have given the path, and then I can click run. So now it is giving me the data set, the entire data set. So right now our index column for each row is 0, 1, 2, 3 up to so on. Similarly for column index, that is also from 0, 1, 2 up to so on, as well as the column name is date, day, month. Okay, so that is basically the bike store sales data, that is on date wise, day, what was the day, and what was the month, which year, what was the customer age group. So these are the different variables we are going to use for analyzing it. Okay, so we will check that what kind of these variables are, because for the analysis purpose that is very important. Similarly, what was the customer gender, country, state, product category, sub-product category, and so on. Now, the first thing what we are going to do is how we can save this entire data set into a single variable. And this is very good practice because instead of every time we are calling that data set, it's better to store in a particular variable. So because this is a sales data, so that's why I'm writing down pandas dot. Okay, so you can also do that dot. If you write down, press the tab button, you will get a list of functions that are available. So right now, what function we are using? We are using read underscore CSV. As you can see that we can also read Excel format file, and there are multiple type of format, JSON format, HTML, and many more. Right? So because our data set is in a CSV, that's why I have written down read underscore CSV, and then again, so we are basically what we are doing over here, we are storing the data in a sales variable, right? So right now, if I write down again, insert, if I write down over here is sales, I can run it, I can see the data set. So there is a two-way to run the command. Either you can click over here, run, or either you can use your keyboard shift, press shift while holding the shift key, press enter. So you can run the command. Okay, the next thing is the good practice is while using any particular library, we should import that particular library with respect to its ALEs. So right now, instead of using again pandas, so we are using import pandas as PD. So based on as PD, so that means whenever I want to use any pandas function or a attribute, I can, instead of using pandas, I can use PD. So we can run it, and then again, as you can see that instead of writing pandas, I'm using PD dot read dot CSV and then giving the path and storing into a particular variable, that is sales. Okay, so now the entire data set is stored in a variable that is called as sales. So this now we were, because we are going to use plotting, or you can say visualizing the data set. So for that, I'm using a library called Matlab Plot. So first of all, I'm going to call this library import matplotlib.pyplot as PLT, and this is a magic line that all the graphs must be in line while they are showing us in an output. So once we run this one, and the next thing, if I want to see that the value count means that is just counting us how many data entry against June, how many data entry against December, and so on. So first of all, we are accessing a data column variable, or you can say a column, and then we are counting the number of values. Okay, so it will giving us me the you can say uh, the number of values. So right now, because we started the analysis of the categorical type of variable, so let me show you so what kind of analysis we can perform descriptive analysis on the qualitative data. So for qualitative data, that means that is countable data that you cannot measure it. Okay, you can just count it. So for that, if we can use the descriptive analysis, either the tabular form or a graphical form or a number in terms of percentage. So one way table is indicating what? One way table is indicating if you are um, analyzing with respect to a single factor. Like as I am showing that right now we were analyzing with respect to the month. So month is a single factor, so that's why we can apply one-way analysis. So this is one-way table as well, right? So similarly, if there is a two factors, means you are you want to see that the number of counts with respect to month as well as in a country. That means how many customers came for buying the bike in a bike store in a particular month. So that is a two factor. One is a country, and another is a you can say month. Similarly, if you increase the factors, like there is a three factor, one is a product category, another is a month, another is a country, then it would be called as a three-way table, right? So against one-way table, so either you can apply the simple bar chart or a pie chart, but against two-way or more than two-way, you can apply the multiple bar chart as well as called as side-wise bar chart. Okay, side by side bar chart, and then either you can apply component bar chart, which is also called as stack bar chart, right? So first of all, because I am considering a single factor which is month, so this is a one-way table I am showing. So in order to plot it or graphically, so we can use simple bar chart or a pie chart. So how we can draw the simple bar chart. So I am using sales month dot value count, that we are counting the number, and what kind of plot. So that means this command is the same as we have used over here. After that, dot plot, and what kind of plot we want to draw is, that is a bar plot. Then we are giving the figure size, okay, so that you can reduce it. If you want to use the small size, you can use 6 by 6, and then we are storing into a variable that is called as cell, okay, and then we are giving the name of the y-axis, that is cell dot set underscore y label. Similarly, you can also set the name of the x-axis, that is cell dot set underscore x label, okay. So you can also write on that one. So if I run this one, so I can see that I have reduced the size of the graph, and then on x-axis we can see the months, on y-axis we can see the number of customers. So that means usually in June, May, and December we have the highest sale, and then the lowest sale in July, okay. Similarly, we can use another factor, which is age group. That is again a one way, okay. Again, I am plotting it. So same graph I am using with respect to the age group. If you want to analyze how much sale is occurring with respect to the age group. So right now we can see that on a bike store, so the most of the sales are coming from the adults or the young adults, okay. So the most of the sales over from this group, or either from the one-way table you can use the pie chart. So in order to draw the pie chart with respect to the product category, mean how much share of the sales of these categories, that is sales product category dot value count, then in kind we should write down pie, so we can see the pie chart. But there is no labeling over here, because sorry, similarly there is the age group, so there is no labeling over here. So if you want to label it like what percentage of this portion is, so in order to do that we will write down sales group dot value count, same. So we will add these two lines, that is auto pick percentage, that is percentage 1.1, mean after fraction only up to one digit, show me the number percentage. Then we are saying that the starting angle is 90. So that means it will start calculating the area of the pie at a 90-degree angle, right? So this is this one. So if we can change this one. So instead of 90, right over here I'm using 140, and instead of I want to take it after fraction one digit number, I want to take it up to two digit numbers. So that's why we are using 0.2. Okay, so we can see that we have the labels, as well as it will also showing us the proportion, or you can see the percentage of every area. Okay, now we are going to talk about how we can develop a two-way table. Okay, so how we can develop a two-way or a three-way table. So in order to develop a two-way table, so I'm using group by function. So sales group by, country, age group. So these are the group by, that is basically with respect to country, and in country we have all the age group, in next country we have all the age group, and then we are counting it. So that means in Australia, how many adults that are lying between 35 to 64, and how many seniors, how many young adults, and so on. Okay, and this is basically in a stack form. If you want to do it in an unstack, meaning in a proper tabular form, so you can just add another command dot unstack. So it will look like this way, which is, I think it's a good representation. Okay, so because this is a two-way table, it's a counting data, so we can use either multiple bar chart, or either we can use a component bar chart. So first of all, I am drawing the multiple bar chart. So how you can do that? So same as we have used the upper command. So same command dot plot kind, and then you need to write down stack false if you want to draw the multiple bar chart. All right. So if you want to apply the stack bar chart, which we call as component bar chart, then you should write down true. So this is, I'm giving the y-axis label as well as the x-axis label. So if we run this, we can see that country, and then these bars are representing the age group, and y-axis basically indicating the number of customers. So if I run this one, so I can see that y-axis is the number of customers as well as x-axis is the country. Okay, so this is the only difference is stack is true. The same is I have y-axis label, the rest of this one command is the same. Now we can see that this is a stack bar chart. So basically these bars are representing the multiple bar chart. That means over here in Australia, how many adults customers are coming. In Australia, how many seniors are coming, okay, in that, but those stores. Similarly, these are also indicating the frequency, but in a cumulative form. So overall Australia, how many customers are coming, the proportion of, or you can say the number of customer in adult, and from here to here the number of customer of the young adults, and so on. Okay, the next thing what we are doing, we are getting the descriptive statistics. So descriptive statistics mean that it will give us the number of data points in the data set, average value of all the quantitative type of variable. That mean those variable which they have shown in an integer form. Standard deviation, minimum value, the first quartile, median value, the third quartile value, and the maximum value. And how you can interpret the first quartile? The interpretation of the first quartile is that is at least 25% of the customer, or you can say, let me interpret this one. At least from the 25 customer who came to the store, we are getting the profit $29 or less. Or you can interpret this way, at least 75% of the customer giving us the profit of 29 or more, right? So similarly, we can interpret this one. This is basically the third quartile, and we can interpret that at least 75% of the customer who came to the store giving us the profit of $358 or less, or you can say that at least 25% of the customer giving us the profit of $358 or more, right? Similarly, this was if we write down sales.describe, so it will giving us the whole data sets, all the quantitative variables, descriptive analysis. But if you want to get a particular columns descriptive analysis, so you can access this way dot describe, so it will giving us only the unit cost descriptive analysis. Similarly, if you want to get a particular, instead of all the descriptive analysis, you want to calculate the mean, how you can do that. Similarly, median as well as the standard deviation. Okay, so similarly, now we can using the group by in order to calculate the average. Okay, so like sales, we are grouping with respect to the age group and calculating the average value of the unit cost, and dot group by we are indicating. So that means age group wise we are basically grouping it, and we are calculating the average of unit cost. So similarly, we can calculate the descriptive analysis of against every you can say age group, right? But the problem with the pandas function describe is it is giving us the count, means the number of data entry against each you can say part of the variable, that is in age group, that is adults, how many adults are lying in this particular data set. Similarly, mean, standard deviation, minimum, 25% mean Q1, Q2, or you can say median, Q3, as well as the maximum. But if you want to get the confidence intervals or the standard error, then you need to call this package, or you can say this library. So I'm using this library research by just to show you that most of the times people like to report the number of values, the average value, the standard deviation of the data set, the standard error of the data set, as well as the confidence interval. So in order to do that, instead of using the pandas describe, so you need to call this library. So I'm calling the research py as RP, and the function I'm calling it summary underscore count, CUNT, continue. Okay, then we are saying sales, that is unit cost, group by age group. So age group wise we are grouping it, and the descriptive analysis we are calculating of the unit cost. Okay. So usually people like to report this way, the descriptive analysis. Now let's discuss the pivot tables of the Pandas library. So pivot tables exactly like as we use in the you can say in Excel. So how we can use it, like we can use pt.pivot table. Okay, that is the function from the pandas. Then we have to write down the name of the data because we have stored the data in a sales, comma, then we are saying that index is age group. So index of age group means that we should pivot it with respect to this one, or you can say group by this one. Okay, so as you can see that this is group by, so this is showing me the group by, right? But once we do that, it will give me grouping with respect to this variable, that is age group, and show me all the quantitative variables. So once we run this pivot column, so cost, customer age, day, and so on. Okay, but if you similarly, if you want to pivot it with respect to two variables, the same thing in index we are writing down customer and age group. So right now we are pivoting it with respect to country and then age group and so on, right? So if we want to pivot it with respect to country, but on a y-axis instead of the whole data set, we want to see the average of the profit against every country and average of the unit cost. So we can use this command. Then this is the name of the data set. So this is against country. We are saying that average profit and average unit cost, okay, against each product. Similarly, the advantage of the pivot table is that you can also report the multiple descriptive statistics against each, you can say, the particular factor. Like right now, country, I want to compute out only the mean value, the median value, and the standard deviation of the profit as well as a unit cost. So how you can do that? So for that, I'm using the NumPy libraries function mean, median, mode, because if you want to use the pivot table, so in order to calculate the average as well as the standard deviation and the median, so means the descriptive analysis, so then you need to call this NumPy library. So that's why I'm calling import NumPy as NP. Then pt pivot table, name of the variable, then index is with respect to country, and the values. So that means the quantitative variables are the unit cost and the profit. And then agree function is that we want to calculate the mean of these two variables, the median of these two variables, as well as the standard deviation of these two variables. So mean of the profit as well as the unit cost against this one, median of profit and median of cost, similarly the standard deviation. So similarly, we can use it with respect to the name of the data set, and index is country and age group, and then values. So that means country, and then the sub further we are pivoting it with respect to age group. So in country, how many adults, having providing us the average profit and average unit cost occurring on that group. So this kind of information we can get it with respect to the pivot table. Okay, so I hope this is clear. And now if you want that like instead of calculating all the variables, like against unit cost, it will provide us mean, median, standard deviation. Against profit, it will provide us mean, median, and standard deviation. But if I want that against unit cost, it will show me only the mean. But against profit, it will show me mean, median, and standard deviation. So how you can do that? So for that, we need to use this command, the following command. This one is the same, but in agree function, you should call it. For profit, I need only the sum of the profit. Okay, np dot sum, that is basically the, you can say we are calling the attribute of the np library. And then unit cost column of this particular variable, I need sum as well as mean. So now you can see that in our output, when we are show calling it, means getting the result from the p table, because we have stored in this particular variable. So against the profit, we can only see the sum, as well as against units cost, we can see mean as well as the sum. Similarly, in order to do further filtering it, like if I want to get like this is the data set, and I want to see only the analysis of the United States country. So we can use p table, because we have stored this table in a particular variable. Okay, so this is generally called as the advanced filtering it. And then I'm calling a function called query, then country equals United States. So it will showing me only the countries wise we are filtering it against that age group, and then the results which we have calculated over here. Similarly, if you want to get the two countries, okay, Germany as well as the United States, so you can use this one. Okay, so I hope the pivot tables as well as the group by area is covered. And till now, in a graphical analysis, we use one-way table, we use bar tables, we use two-way and multiple bar charts. But till now, what we have done is that we were just counting it. Suppose if we want to plot a bar chart against the sales perspective, mean a quantitative variable perspective. So how you can do that? I'm saying that calling the column variable, that is country, and the quantitative variable is a unit cost, and grouping it with respect to country, and I want to calculate it the mean value of the unit cost. So that means I want a graphical plot that must show showing me the average unit cost is agreeing against each country. Okay, then I'm calculating mean, unstacking it, then plot bar chart, okay, kind. Then I'm giving the y-axis label, x-axis label, and the title of the graph. That is because this is the name of the variable. Then name of the variable dot set underscore title. This is this way. So this is the way we can label the y-axis. We can label the x-axis. We can give the title. If we run this one, so we can see that average per unit cost against Australia, Canada, and so on. Okay. Next, what we are doing it, we are getting only the average. We are also want to see the error bars, or you can say the standard deviation bar. So this is the average per unit cost against each country. So we also want to see that how much variation in the product per unit cost are occurring. So for that, what I am doing, first of all, I'm grouping with respect to the country, sorry, that is group by, and then I'm calculating the sales in order quantity. Okay, that means how much order is coming, average order coming from the particular country. Similarly, how much variation in that order quantity is. Okay, so this is we have grouping it, we have calculated the average of against order quantity variable, we have calculated the standard deviation against order quantity variable. Now in order to plot it, what we will do is we will use fig sale is equal to plt dot subplot, and then we are writing down mean dot plot because we want to draw the average plot. So mean dot plot dot bar, that is a type of bar, and then YERR, that is the same would be in which we have stored the standard deviation, and then axis is equal to sale, that means the original variable. So caption size, that is, this is a caption size, figure size, and then this is the same, we are giving the y-axis label, x-axis and z-axis. So in this particular graph is what is it is indicating, this is the average, not a unit cost, this is order quantity. So let me run again. So if I run this command, so I can see this one, that this is indicating me the average product order quantity. So this is the average product order quantity and how much variation in that order quantity in this particular country, that is in Australia. Okay, so basically this is the average value, and this is basically the plus standard deviation from the mean, and this is minus standard deviation from the mean. Okay, so similarly, if you want to change it color, so all the things are the same, just I am using color is sky blue. So whatever, if you want to change the colors, colors of the bar. Okay, next, for the quantitative data analysis, if the variable is a quantitative, so in a tabular form, we can either report it a frequency distribution or a stamp and leaf. But for graphic representation, we can use either dot plot, histogram, or a box plot to check the shape of the data, or you can say to quantitatively describing the data. So right now we will talk about histogram, box plot, as well as another plot is a pie plot, violet plot. Then we will also discuss that under what condition we can apply mean, median, mode, right? We have discussed the median, quartiles, and then I will also discuss under what condition we can apply range, IQR, and variance, these things. So let me start first of all by plotting the histogram. So how you can plot it? Again, I'm storing the variable sales unit cost. So we are accessing this particular variable and we are plotting the histogram using the command kind hist. Okay, again, this is the same y-axis label, x-axis label, and we are plotting the histogram. So right now we can say that what kind of shape it is, that this is indicating the, you can say it is look like a exponential type, or you can say the positive skew type of curve. So that means the sale is a positive skew. So that mean right now it is basically a unit cost. So the majority of the product you can say which having the lesser per unit cost is having the higher sale. On this particular graph we are getting it. Again, one more thing is that over here we are not representing how it should be classified. Like in histogram, although it is look like a bar chart, but the difference is in histogram the bar width is also important, which is called as a bin, right? So each bar width basically is indicating the class interval or the width of the bin. So you can also control the width of the bin. How you can do that? So the good practice is, first of all, get the minimum value of the data, the maximum value of the data, and the rest of the command is the same as I used earlier, but only I'm adding this bin. So I have written down the minimum value number 1, the maximum number. In between, I use the class interval of 400. So that is 400, then 801, 1201. So in order to control the width of the bars. So again, it is look like a positive skewed, means the similar kind of information we are getting, that lesser the cost, higher the sale would be. Okay, but let me tell you that if the shape of the graph is a symmetrical form, then you can calculate the average value with using the mean. Okay, and how you can find out the standard deviation of your data set? You can use the means how you can find out the variation. If the data is symmetrical, always use mean and standard deviation to find out the measures of variation. But if the data is a positive skew, in having the right tail longer, or either it is a negative skew, okay, or you can say left tail longer. So in order to compute out the center point, always compute the median value, and in order to compute out the variation, always find out IQR, that is interquartile range. Why we are using this one? Because due to the skewness, there is a high extreme value in the data set. So IQR will ignore the extreme points, as well as median will also ignore the extreme points. Whereas mean and standard deviation are mathematical average as well as the mathematical standard deviation, because the standard deviation is also calculated based on the mean value, mean all the data sets are using. So that's why extreme points are affecting the answers of these values. But if you have a bi-model or a tri-model, then in order to compute out the average value, try to use mod, and in order to compute out the variation, try to calculate range. Right? I hope this is clear. So similarly, instead of drawing the histogram, we can also apply the simple density plot. Okay, so it's in kind hist, we can use density, so we can also this one. So actual graphs start from over here. Okay, so this is the density plot. So if you want to on a density plot, if you want to plot the mean value, so you can also do that on a histogram as well. So this is the density plot. So over here, what I am saying, that is x is vertical line. So that is on x-axis, I want to draw a vertical line, of what? That is average of this one, and what's the color. Similarly, vertical line of median, the color is green. So this is indicating the median cost per unit cost, and this is indicating the mean value. Okay, similarly, we can also use the box plot instead of the histogram. So box plot, what it will show us, that is, we are drawing the box plot. The card is the box. Okay, so the idea over here is, it is basically showing us that basically these are basically the extreme data points. If you can see that the upper one is basically the Q3. So basically in a box plot, we can see these lines. Okay, this is called as the value of the Q1. This is the value of Q2. This is the value of Q3, or you can see the third quartile. This is called as lower whisker, which is calculated Q1 minus 1.5 into IQR, which is interquartile range. And this is Q3 plus 1.5 into IQR, which is you can say the upper whisker. So if any data point is crossing over here, or this particular data point, we will say that these are the extreme data points. So we can see that there are few products which having the higher per unit cost. So right now this is a default representation. So if you want to draw it in a horizontal form, so you can use vertices false. So now we can see that in a vertical form. As you can see that this is the upper whisker, this is Q3, and this green line is a Q2 value. Okay, so the next graph is a violent plot, which is actually the combination of the histogram as well as the box plot. And this is the very good representation. As you can see that this is basically the lower value, as well as right now over here you can see also the average value. And this density is basically indicating, you can say, the fluctuation or the variation in the data points. So this basically, whenever you are seeing this one, this is indicating the fluctuation in the data point. So how you can draw this one? You can use PLT, that is a Matlab Plot library, we are calling it, dot violin plot, sales unit cost, and we are saying show median. So this is basically also the median value. So the next thing is, again, we are drawing the box plot, but right now what we are doing, instead of only drawing the box plot overall unit cost, but we are grouping it with respect to the country. So I want to compare it per unit cost in every particular country of the product. So then that is sales unit cost. Okay, so this is a variable we want to calculate it, or you can say draw the box plot with respect to country. So box by country and then by axis. So this is the representation. We are seeing that on x-axis. So every country wise we can see the per unit cost of the product. Okay, so we can see that where the products are expensive or where the products are not expensive. As you can see that on average, almost in every country, the average product costs are the same, but there is a variation. Like the very less variation in the Canada as well as in United States. Okay, the next thing is, if I want to draw the multiple variables on a single graph. So there is a like unit cost, unit price, and profit. Okay, so as you can see that the box plot of the unit cost, box plot of the unit price, and box plot of the profit. But this is not a good representation. Why it is not a good representation? Because like the profit, they have different scale, maybe they have the higher value, and unit price and unit cost having the lesser value. So the better representation would be if you use on this particular command, this one means for every variable we are drawing it separately, but as well as in a single graph. That is basically sales unit cost, unit price, profit dot kind box, and then subplot is true. So due to this, it will showing us unit cost separate graph, unit price separate. Now you can see that every graph has their own y-axis scale, but over here they have the same scale. So that's why this is not a good representation if their scales are varying. And lastly, we are calculating if there is a two quantitative variable and we want to find out the relationship between two variables. So we can draw the scatter plot. So right now I want to see that what's the relationship between revenue and the profit. So you can easily see that as the revenue increases, the profit will also increase. So sales dot profit, kind is scatter, x-axis revenue, y-axis profit. So we can see that they have the positive relationship. So I also calculated the correlation as well. So we can calculate the correlation of between these two variables using this particular function dot correlation from Pandas. So we can see that they have the 95.95 correlation. So that means 95% of the time as the revenue increases, the profit is increasing. I hope you understand how we can use Pandas library as well as the Matlab plot. Thank you so much. See you in the next video.